everyone, my name is Gleb. In this video, we're going to create 4D objects and rotate them in 4D space using only Blender and geometry nodes. This is the famous visualization of a four-dimensional cube, also known as a hypercube. It is made entirely in Blender. But that's not all. You can also use this modifier to rotate any other objects in a 4D space. Here, for example, I have a tetrahedron. I will turn off this modifier. Here, this is a simple tetrahedron, and with this modifier, we make this tetrahedron four-dimensional and rotate it in a four-dimensional space. Here, this is a simple plane. This was a simple plane, and when we extrude it, it becomes a cube. And this cube is being rotated in a four-dimensional space. And here we can even rotate Susanna. Okay. Let's create a new file. Select Geometry Nodes Editor and let's create a new modifier. I will call this modifier hyperdimension. Okay, first of all, I need to extrude it along the fourth axis. To explain this, I can use this analogy. Here we have a 2D object, plane, and to make this object three-dimensional, we need to extrude it along the third axis, and it becomes a 3D object. And to make this 3D object four-dimensional, we need to extrude it along fourth axis. To extrude this whole object, I can use Extrude Mesh modifier and select edges here. Right now, all edges are being offsetted along the normals. But that's not what I want to do. I will set this offset to 0, but extrusion still occurs. I can demonstrate it moving it. Here I have a selection of only extruded part, and here I can offset it. I select wireframe mode so you can see what is happening. Here we basically we create a second copy of a 3D object, and all of the vertices of this copy are connected to their corresponding vertices with just simple lines. But that's not exactly what I want to do, because right now, as you can see, I offset this extrusion along some axis in a 3D space, but I want to extrude it along fourth axis. It's usually it's called double V, along double V axis, and here in this offset we don't have this value. I will put these values to 0, and I need to add this fourth value, and this is surprisingly simple to do. Here I already have a field of Boolean values that corresponds with the extruded part, and all I want to do is convert these Boolean values to float values. To do it, I can use switch node. Here I need to select float value as an output. I input Boolean values, and in case of false it's going to be -1, and in case of true it's going to be 1. What this means is that every vertex in this geometry is corresponded with a float value, and -1 means that this is original geometry, and extruded part is corresponded with 1 value. it basically it's this fourth dimension. This value shows where this vertex exists in a 4D space, and every vertex of the original geometry is located on a -1 along the W axis in a 4D space, and each new vertex that we make with the extrusion now lives on a 1 coordinate in a W axis in a 4D space. So basically this means what position each vertex has in a 4D dimension. Okay, but right now we just declared this position and we don't use it. To actually use it, we need to rotate this 4D object and then project it into 3D space. And let's start with the last one. Let's make a custom node that will take 4D vector and project it into 3D space. To do it, let's start with vector math node and create a group. And here, as an input, I want to have a vector, and then second value is going to be float, and I will call it W. It's fourth component. Basically, in input, we need to have 4 components. This does the same, because a vector consists of 3 components, and W is fourth component. And as an output, we need to have just a single vector. The easiest way to make this projection is just to drop W coordinate. This means that we simply flatten this 4D object. But I want to make something more sophisticated. I want to make a perspective projection. And I found a formula, this one, in a coding train video, which I highly recommend you. Here, I need to multiply each component of this vector by this W value, where distance is a distance from the camera, and rotated W means just this W value. I will make vector math node and multiply it by one divided by distance from the camera. I will make it 2 minus W value. I just implemented this formula that I've just shown you. Okay, here I need to input positions of vertices and W value, and output it here into this position. And I need to cut this selection, because I want to apply this projection to the whole object, not just some part of it. I will rename this node as 4D to 3D projection. Okay, it's already looks like something that we need to do, but this is not all. I need to also apply rotation to the object. We have vector rotate node, but this node only works with 3D vectors and outputs 3D vectors, and I need to rotate 4D vector, and I need to implement this node myself, because Blender doesn't have it. Now I need to apply rotation of this 4D object. To do it, I need to multiply every 4D vector of this object onto so-called rotation matrix. I'll show you this here. To rotate object in 4D space, we can use any of these matrices, but I will use the last one because it's the most common, XY rotation. I need to multiply 4D vectors by this matrix, and I will get 4D vectors. Let me reorganize space a little bit. I create new group. As an input, I need to have a vector and a W value. It's the same as having a 4D vector as an input, and as an output I need to have the same. Also, in the input I need to have angle value, angle of rotation. Here in the middle I need to make matrix vector multiplication. Because Blender doesn't have this node, I need to implement it myself. Here is the formula that I am going to use, vector matrix multiplication. I'm using last matrix. This once means that I will use x and y values intact. I use separate x, y, z and combine x, y, z. I pass x and y values as is. Then I need to multiply cosine of angle by z, multiply minus sine by w, and add them together. So I need to use add node, and this is going to be z value. Here I need two multiplication, to multiply by cosine and to multiply by sine. I add together two multiplications. First one is cosine, second one is minus sine. So I need to multiply sine by -1. I multiply cosine by z, and I multiply minus sine by w. And as an input for cosine and sine, I need to have angle. Angle. And this was third row. I need to do the same for the last row. I need to add together these two values, and it's going to be w. I need to add two multiplications together. First multiplication is z multiplied by sine, just sine without minus. And second multiplication is cosine multiplied by w. If everything is correct, it should work. Have this working custom rotation. I will rename it 4D rotation by XY plane. Before projection, I need to make this rotation. So as an input, I will have these positions and W value, and I will put output here. And here, by adjusting this angle, we get this rotation that we wanted. Okay, almost all work is done. Last thing I want to do is make animation. I will use scene time and connect frames to angle. But right now angle is in radians and it's not very convenient. I want to translate degrees to radians. It's a math node. Here I will add multiplication, not just for convenience, to make animation faster or slower. And in timeline, I will make 180 frames because now each frame corresponds with an angle, and this means that our animation will be looped when object rotates 180 degrees. So we will have a seamless loop. Okay, let's check if it works. Okay, this loop looks seamless. And to make final adjustments, I will use if renderer and apply wireframe modifier, and I will also apply emission shader. But you can use any visualization you want, and for world I will use white background. And also I need to set viewport quality to 1 to see it live. Okay. But the most fun part is that when we can now use this modifier to any other objects. I can create a tetrahedron. It's just a simple cone with 3 vertices. I will apply all transforms just in case. And I need to apply geometry nodes, hyperdimension. And also I need to apply wireframe and apply material. Here we just created another object very simply. Thank you for your attention. Bye.